So just revisiting graphing polynomial functions. So to do so, let's just find the degree first. So here you have an x, but there's a square outside, so that makes it x to the 2. And there's an x here to the 1, and there's x to the 1. So 1 plus 1 plus 2 is 4, so this is degree 4. The leading coefficient, no, the leading coefficient, there's a 1 here, there's a 1 there, and there's a -1 there. Overall is going to be -1. So that's your leading coefficient. The x-intercept, you have to calculate. So what you do, g of x equals -x, x plus 1, x plus 2 squared. Now, if you make g of x 0, then you know your x-intercepts will be 0, -1, and -2 just from the factored form. Always we want to find, if we want to find the x-intercepts or the zeros, we always factor. Since this is in factored form, then it's easy for us to tell what the zeros are. So it's 0 from here, that's -1, that makes the 0, and then -2. Well, remember that -2 is multiplicity of 2, so that's m is multiplicity of 2. The y-intercept, so you do g of 0, you make x 0, then you'll have -0 and 0 plus 1 and 0 plus 2 squared. Now, because this is 0, when you multiply it, then anything, it's all going to be 0, so that y-intercept is going to be 0. Always know if you have an x-intercept of 0, then the y-intercept is going to be 0 as well. So let's go ahead and plot the numbers that we have here. So we have an x-intercept that's 0 and a y-intercept that's 0, so that's right there. We have -1 and -2 right there as my x-intercept. So I have 3 x-intercepts right here. Now, x equals 0 is a multiplicity of 1. X equals -1 is a multiplicity of 1. And x equals -2 is a multiplicity of 2 because of the square on top. So that's why it's a multiplicity of 2. So now what you do is you go through the zeros, but you go to the 0 furthest to the right and see if you're going to go up or go down. How do you know if you're going to go up or you go down? You look at the leading coefficient, which is negative. So if it's negative, no, for sure your graph is going down. And then after that, you just go through your zeros. So -1 here is a multiplicity of 1. Multiplicity of 1, you go right through it. And then you go back to the other 0. And since it's a multiplicity of 2 at -2, you have to bounce and come back right here. And this is how your graph looks like. Now the end behavior, as x goes to -infinity, y goes to -infinity. And as x goes to +infinity, y goes to -infinity. What does that mean? It means when we say as x goes to -infinity, that means as we go to the left to -infinity, what's happening to the y? Looking at this graph. So you know, as we go further to the left, the graph keeps on going down and down and down forever. So it's going down to -infinity. Also, as x goes to infinity, that means as you're moving this way with the graph, what's happening to the y value? So you know, as we move right, the y value keep on going to -infinity as well. And this is the answer for this one. I'm going to do one more. So here's another one. The degree here is going to be 5, since the square here and the cube there. So that indicates the x has a square and the x has a cube. So it's degree 5 when you add them, 3 plus 2. The leading coefficient, you look just at the axis here. There's 1 here, there's a 1 here. When you multiply them, you get 1 in front of the x. So the degree, just degree 1 or first degree. And behavior, we'll look at that later. The x-intercept, right away, you're making this 0. So if you make this 0 and it's in factored form, you know you have x equals 4, and it's a multiplicity of 2 because of the square on top. And x equals -3, and it's a multiplicity of 3 because a cube on top. How about the y-intercept? The y-intercept, you make x0, so you have 0 minus 4 squared times 0 plus 3, and that's 0 minus 4 is -4 squared is 16. 16 and 3 cubed is 27. So 16 times 27. The y-intercept is 432. So maybe what I'll do, I'll just scale by hundreds here, 100, 200, 300, 400. You don't have to be accurate. I think the end behavior of the graph, that's what we're looking for. And that's -100. Now, we go ahead and plot our zeros. We have them at 4, multiplicity of 2, and -3, multiplicity of 3. The y-intercept is 4, 32. So I'll say maybe around here, give or take. Now, the leading coefficient here, because it's positive in here and positive in there, so the leading coefficient is positive. If the leading coefficient is positive, you're going to go up at this 0. So if the leading coefficient is positive, you go to the 0 furthest to the right and you go up. Now, because we have a degree of 2 there, or sorry, because we have a multiplicity of 2, then we don't go through the 0, we bounce. And then we come back and we should go to our y-intercept. And then when you come here to this 0 right here, it's a multiplicity of 3. Multiplicity of 3 means you go through the 0 for a little bit and then you continue going down. You don't bounce. So that's the degree of 3. And that's how this graph should look like. Now, if you want to do end behavior, you say as x goes to -infinity, y goes to -infinity as well. So as you see, as you go further to the left, following this graph, you're going to the left, but you're going down to -infinity. And as x goes to infinity, y also goes to infinity. Because as you go further to the right, as you see, our graph is shooting up to infinity. And that's the end behavior. This is it for this graph. If you're wondering about the picture on the back there, I just want to say one thing. I congratulate the Libyans for this day, the day where they got rid of Gaddafi, who ruled them for 42 years. And hopefully their struggle to freedom and a civil society and a civil government will prevail. Again, congratulations. And for who you're watching this, thank you for watching. Don't forget, hit that like button, subscribe to see more videos, and also share with others so they could benefit. Thank you again. Bye-bye.